All right, excellent. We are ready to start a brand new unit in chemistry. You learned a little bit of some skills that involved numbers, and in chapter 2, a little bit of significant figures, a little bit of calculations, and we are going to continue to work on that and apply it in this next part here. So we are going to start with something that is relatively straightforward, which is calculating something called formula weights. One of the things about chemists is we don't really draw very much of a distinction between weight and mass. Technically, weight would be the force pulling down, but we'll use those terms interchangeably. Please don't tell Mr. Lizzie about that. So a lot of times these are called formula weights. Self-defining term. You take a formula and you figure out what the weight is of that formula. Okay? There are some other terms. If you're talking about one atom, it's atomic weight. A lot of times this is the molar mass, and that's usually used if you're doing something that is not technically a formula but is more of a organic compound, like say a methane molecule. A lot of times we'll talk about the molar mass, which is abbreviated with two kind of fancy capital M's, molar mass. We're not super picky about distinguishing between these, but you just want to be able to recognize those different terms as being the same thing that we're calculating. Okay? There's different units associated with mass of an atom or a formula. And a lot of times it's grams per mole. And the abbreviation for that is lowercase g per lowercase mol. One of the lamest abbreviations of all time. You abbreviate mole by taking the E off. But you can't really use any of the other ones because M means meter, MO is molybdenum. So we will use that abbreviation for grams per mole. And that's the one that I want you to use. A lot of times biologists will use Daltons for a big molecule like a protein, and that's actually named after John Dalton, who came up with the atomic theory, and that's capital D lowercase a. Essentially means the same thing. Usually those are going to be for huge protein molecules, so they'd be in the tens and hundreds of thousands, so they'll use Dalton. It's just a sort of a different thing. Also, there's something called atomic mass units, AMUs. I want you to be aware that that exists, but we're not going to use that very often. As a matter of fact, I'll give you a little hint here. How about that for a hint? Use grams per mole all the time. After this unit, we're going to talk about how to calculate and convert grams into moles and vice versa. Actually, it's at the end of this unit. How do you convert grams into moles? Well, there you go. By starting with the formula weight, that'll tell you how many grams there are in 1 mole. So that will be the preferred term. I mean, we ain't biologists and don't use Dalton. An atomic mass unit is usually used more, I think, in nuclear chemistry and those kinds of things. And they tend to round it to the nearest whole number, which we are not going to do. We're going to be very exact. Okay? So, how do you do this type of calculation here? Oh, that's a subtle hint, by the way. This right here, subtle hint, like this sign I saw. Soccer just played on. It's a little dig on soccer players. You know why so many people play soccer? Yeah, so you don't have to watch it. It's a little soccer joke there. As many of you know, both of my daughters play soccer, and don't tell them that gave you these jokes. All right, so let's go ahead and do some calculations here. Formula weight calculations. How are we going to do that? Well, here's the type of problem you'll get. What is the formula weight of table salt? Okay, so when you do that, you take one formula unit, and hopefully you guys know that table salt is sodium chloride. Okay, sodium's +1, chloride's -1. You got the formula drawn out there. Okay, so where are we going to find the weight of each individual atom? All right, so I think these new computers have it. Yes, they do. They have the subliminal feature. So I'm going to turn on the subliminal thing, and you're going to see something, but you're not going to know. It goes so fast that you don't really know what it was that you saw. So if you just stare at the screen, I'm going to give you a hint subliminally. Any guesses now as to where to find? Some of you are going to your folder right now and grabbing your periodic table, and you see that sodium has an atomic mass. Oh, wow. And its atomic weight is what they list on here. Again, interchangeable. An atomic weight of 22.989770. Did you see that? I read those tiny little numbers with no glasses. The C-Rex has still got it. All right. Okay. So, that's a lot of numbers to put down. Wouldn't it be nice if we could agree on how many to put down? All right. So, I'm going to suggest this. How about we go one place to the right of the decimal? Okay? So, every time we do an atomic weight, whether it be a small one, a big one, a total, a formula, an atomic, just one atom, we'll go one place to the right. Okay? Now, I believe in getting your input. If you disagree with this, that's fine. I want you to write down your complaints, put them in an envelope, get a stamp on it, and address it to someone who cares. Because we're going one place to the right. Okay? Yes, we're going to vote on it. I see everyone's hands are up. We're good. It's unanimous. Okay? So, really, it's just a suggestion. You don't have to do it. Okay? I'm just saying, please, go one place to the right. If you don't, it's wrong. Okay? And it's red pen. So, flexible, right? It's a free society. You can decide whether you want the point. You want one place to the right. One place to the right. Okay. So, there we go. We're in agreement. Life is good. So, we look at sodium, and you go, it's 22.9, and then that's the one place to the right. And then we say, does the 9 have to round up? So you just look to the next digit, which is, in this case, 8. So it's 22.98. So we have to round it up. 9 rounds up to 0. So it's 23.0. That is the one correct answer for that atomic weight. Okay? No flexibility on that. Okay? So when you're doing these problems, you're going to show me all the individual steps. And we're going to use what is called the circle square method. So what you want to do is find the first atom, which is sodium, and you will put 23.0 on there, and you're going to circle it. All right? So now it's time to do chlorine. So see if you can do this one on your own. Find it, And I'm thinking one place to the right. Yeah, that's what you should do. Okay? So the one single correct answer for that is 35.5. That 4 rounds up because there's a 5 after it. Okay, all you got to do, you have to go 2 places to see if you round up or not. In both of these, you had to round up. Okay, a lot of times there'll be whole numbers like the 23.0, but not necessarily, because these things tend to be all over the board, because if you will remember, they're the average of all the isotopes of chlorine. And a lot of chlorine is chlorine 35, but there's some chlorine 37, about 25% of it. When you average them, you get 35.5. Specifically, 35.5. Okay, now, here's the good news. Once you have established this, and by the way, the mistakes in these tend to be just getting the rounding correct. So take your time to get those individual steps, because that's 2 points already, okay? Just for the 23.0 and 35.5. And obviously, if one of those numbers is wrong, excuse me, then you would have to, you're going to get the wrong final answer too, with it, which is worth more points, okay? Because you got to just add those up. And here's the good news. When you're adding and subtracting, you don't have to count total sig figs. You don't have to say this one has 2, that one has 4, my answer would have 2. You don't have to do that. You just have to go 1 place to the right. See how nice that system is? I think you're going to like it. All right. So 58.5, you got the units, grams per mole. And then the last thing that you're going to do, since it's the circle square method, you put a nice little square around the final answer. Okay, had a nice discussion with a student a couple years ago about the name circle square, and he goes, "Shouldn't you call it oval rectangle?" It's so funny. He's doing a lot better now. The limp is mostly gone. So circle square is what we're going to go with on that one. All right. I keep forgetting these are recorded. You guys could show these to your parents. Look, he hurt a student because he said oval rectangle. I didn't. Okay. We're almost done with the time on this lecture. There's more to cover in terms of writing formula units. So, this is video 1. You have to watch video 2 before you can start the worksheet. Bye.